Okay, now we're going to review rules of exponents. Okay, so I just put down some basic rules here. We'll remember that x to the third times x to the fourth, you add the exponents and the answer is x to the seventh. If you have x to the third raised to the fourth, I call that a power raised to another power. You multiply the exponents and you get x to the 12th. 2x to the third raised to the fourth, you have to remember that's the same as 2x to the third times 2x to the third times 2x to the third times 2x to the third. So we'd have 2 times 2 times 2. Okay, so we get 16x to the 12th. Okay. X to the 0 is 1. Anything to the 0 power is 1. If you have 5 to the 0, that would also be 1. What you do have to remember is if you have 5x to the 0, that's 5 times 1, or 5, not 1, because only the x is raised to the 0 power. And x to the negative 2 is 1 over x squared. So let's simplify negative 12x, y to the third over 2x to the third, y to the second. So I know that negative 2 goes into 12 negative 6 times. So that's the easy part. We'll just handle the numbers. X to the first over x to the third. You're going to bring down the x to the first power. You don't see that 1, and it's a negative 1. And then you would be saying 3 minus 1, or x squared. So you subtract those exponents. Here you're going to bring the y squared up as y to the negative 2. 3 minus 2 is y to the 1. We don't show a power of 1. That's just understood. So we'll have to remember that the variables are going to land on the side of the fraction where the higher variable, where the higher exponents started. Okay. So now, when I have a whole parenthesis raised to the negative 3, I think it's easiest to think about 1 over 2x to the third, y to the 0, z to the negative 2, raised to the positive 3. Or we could have done a power to a power. I guess it doesn't matter one way or the other. So now, if you put 1 over this, we can have a positive 3 and call this 1 over power to a power, 2 to the third, x to the 9th, power to a power, you multiply them. Y to the 0 is 1. 1 to the third is still 1. We don't need to multiply by a 1. And z to the negative 2 raised to the third is z to the negative 6. And then all negative exponents should flip over the fraction line and become positive. So we'll bring that up as a positive 6, leaving me 8x to the 9th in the denominator. Okay, and the last one. If we have a negative 3 exponent, again, you could raise each variable a power to a power and multiply them, or flip the fraction upside down, take the reciprocal, x to the negative 1, y to the fourth, z, over x to the third, y to the 0, z to the negative 2. And then you can call this a positive 3, which is somewhat easier. Now, it might be easier to simplify inside before you raise it to the third power. So you might say, maybe an easy way to do this is to bring the x to the 1 down, and now you have x to the fourth. Y to the 0 is 1, so you keep your y to the fourth in the numerator. The z to the negative 2 can come up as z to the positive 2, giving you z to the third. And now if you raise this whole thing to the third power, you have a power to a power. So that's going to be y to the 12th, power to a power you multiply, z to the 9th, over x to the 12th, power to a power. And everything is simplified.